Hello everyone, welcome back to the YouTube channel. Today we are seeing the Maharashtra State Board Subject Science, chapter number 14, Measurement and Effects of Heat. And this is a video part 2. In the first part already we have discussed about the temperature and the heat, sources of heat, units for the temperature, and then the different formulas or the units for the temperature like Fahrenheit, degree Celsius and the Kelvin, and the relation between them, how to convert from one unit of heat to the another. Next is we are going to talk about the different instruments with the help of which we can measure the heat. In that section, the first what we have to discuss is the thermometer. We have a different kind of a thermometer, and the thermometer is well calibrated in the laboratories, and it's made in such a way that we can measure the temperatures. When we talk about the thermometer, the normal thermometer, what it's having at the bottom, it's having the one bulb like structure, in with that the fluid is stored. Specifically, we are using the mercury in this, and as the heat is received by this bulb, the liquid mercury starts to expand, and that expands in this particular capillary tube which is inside the thermometer. The reading scales are already calibrated or marked on the thermometer, with the help of which we can read the temperature. Like here they have shown, so this is a mark, so it is something around the 27 or 28 degrees Celsius as a temperature. We have the clinical thermometers also, the small rod like structure we are having for the clinical thermometers. This kind of a thermometers you might have seen with the doctors. Now the some more types of the thermometers we have. You can see over here as a digital thermometers are available. Here we have the sensor which senses the temperature, and there is a digital display on the thermometer which shows the digital readings for the thermometer. Next is we have the maximum minimum thermometer. Here it's showing the both maximum and minimum temperature. Two sides we have the scale for the temperatures, and it shows the minimum temperature as well as the maximum temperature of that particular zone or the site. The next what we have to study is the specific heat. The specific heat of an object is nothing but the amount of the heat required to increase the temperature of a unit mass of the substance through 1 degree. In a simple words, this is a definition I was reading about the specific heat. That is, the specific heat of an object is the amount of a heat required to increase the temperature of a unit mass of that substance through 1 degree. This is nothing but what this scientific definition. In a simple words I am giving, suppose if you have a 1 gram of water and you want to increase the temperature of that particular water, or the instead of a 1 gram, take it as a 1 kg sufficient quantity. 1 kg, the unit mass, if I am taking SI unit, the 1 kg of a water, if I am heating it and I am supplying a heat to it, and I want to raise the temperature of a water by 1 degree Celsius. Suppose initial temperature was a 25 degrees Celsius and I want to bring the temperature at a 26 degrees Celsius. Then the amount of a heat required to raise its temperature by 1 degree Celsius, that will be called as the specific heat of that particular substance. So to measure that, we have the formula, the amount of heat required to raise the temperature of a particular substance. Like here, this C is nothing but the specific heat capacity. M is a mass, and Tf minus Ti means the final temperature minus initial temperature, means the difference between the temperatures. Here they have given some of the substances they have mentioned over here, and their specific heat capacity also they have given. Specific heat, now for the aluminium they have given is a 0.21, alcohol is a 0.58, gold is a 0.03, hydrogen 3.42, iron 0.11, copper 0.09, mercury 0.03, and the water is 1.0. So water is a standard actually we are choosing as a 1 calories per gram degree Celsius. So this is about the specific heat. Now to measure this specific heat, we are using a device called as the calorie meter. Now this calorie meter, first we will talk about this calorie meter. What exactly is a calorie meter? How it looks like. So this is the diagram for the calorie meter. We have the wooden box. This is a wooden box. Inside that we have a one copper vessel or the inner vessel, and we have insulated materials over here. It is an insulated material, means which protects the loss of heat through the vessel and the calorimeter. And in this we have inserted thermometer and the stirrer. What exactly we are doing? We are taking a liquid inside this. Let's see what exactly we have inside this. We have the liquid, and we add the different kind of the materials in that for whichever we want to calculate the specific heat, that we are inserting inside that and then stirring and noting down the change in the temperature with respect to the time. So that gives us about the specific heat with the help of the calorie meter. And we are using the same formula, that is the Q is equal to M into C into delta T. Instead of writing this TF minus TI, we are writing over here as a delta T also. This is also okay, means the change in the temperature. It can be positive, it can be negative. Now here some of the things they have mentioned over here. Let's call the final temperature TF. The total heat given away by the object is a QO object, C for the calorimeter, and W is for the water. So calorimeter and water, whatever heat they are absorbing, that will be equal to the heat lost by the object. Now further, what we are supposed to do over here is to write all the values over here. For the object, it will be mass of the object, change in the temperature of the object, and the capacity of the specific heat of that particular object. Similarly, for the water and the calorimeter, we can write, you can see it's all the formulas are nothing but what? M into C into delta T. Now the further is resubstitute in that particular formula and we will get the relation. So this will be much clearer when we will go towards the numerical sections. There we will discuss it in a detail how exactly to use this particular formula to solve the numericals. Now the further what we have to study is the expansion or the effects of the heat. What exactly the effects we have? The most important effect of the heat is the expansion. Whenever there is an increase in the temperature, the all substances expands. Now this expansion, when we talk about, when heat is given to any substance, its temperature increases and it expands. The expansion depends on the increase in the temperature, solid, liquid, and gases, means which particular material we are having and how much heat we are supplying to it. On the basis of that, it expands. Further is expansion of solids. The first one is a linear expansion. When we talk about the linear expansion of a solid, the increase in the length of a wire or the rod of a solid due to increase in its temperature, that is called as the linear expansion, means the length of a particular object is increasing, that is called as the linear expansion. You can see they are mentioned here. If I'll just zoom it out, you can see L2 minus L1 is directly proportional to the L1 into delta T, where L2 is a final length, L1 is an initial length, and delta T is a change in the temperature. So change in a length is basically in a direct proportion with the product of the original length and the change in a temperature. And then with the help of this we can derive a formula where we can write L2 is equal to L1 into L plus del lambda into delta T. Further, when we talk about this lambda, the Greek alphabet is a constant of a proportionality and it is called the coefficient of linear expansion. It's called as the coefficient of a linear expansion for the particular material. It is a constant value. Suppose if I'm talking about iron, so that value will be fixed. If I'm talking about the gold, it will be fixed. If I'm talking about the silver, it will be fixed. So this is about the linear expansion. Now, the next what we have to discuss is the areal expansion of solid. Similar to linear expansion, the area of sheet of a solid material also increases on heating. So first we discussed about the wires. Now suppose if instead of wire we are having a flat sheet of the material, then the size or the area of that is also expanding or increasing. This is given by the formula A2 is equal to A1 into 1 plus sigma into delta T. So this is about the areal expansion, and here of course that the sigma is nothing but the coefficient of areal expansion of the solid. Next one is a volumetric expansion of the solids. Here also what we have, same way the volume of the object or the solid is increasing, and the formula is on the similar basis, that is V2 is equal to V1 into 1 plus beta into delta T, and beta of course is a volumetric expansion coefficient of solid. So this is about the expansions in the solid. The next what we have to discuss is about the expansion of liquid. Like we have discussed in the solids, exactly same way we have the expansion in the liquids also. A liquid does not have a definite shape, but it has a definite volume. So when we heat it, the volume of the liquid is expanding or increasing. And the exactly same formula what we had in the solid section, same we are having here also, that is V2 is equal to V1 into 1 plus beta into delta T. Further, the next is the expansion of a gases. Here also same way, the volume what we have is increasing when we heat a particular gas, and the formula is the same, that is V2 is equal to V1 into 1 plus beta into delta T. So this is about the expansions taking place in the solid, liquid and gases. So this is about the chapter number 14. It's all about the theory. In a coming video, we are going to discuss about the numericals from this chapter.